Hi, in this 30-minute session, the idea is that we're going to go through the basics when it comes to producing equations and using mathematical notation. The major shortcut is Alt equals. We shall use this practically for everything these coming minutes. And if we press Alt equals, Microsoft Word is telling you type your equation over here. Now, a couple of general points, and then we can look at the specifics. If, for example, I have x times cosine theta, cosine is rendered not with a backslash, but simply typing cosine and pressing space. Word recognizes it as the cosine function, and it's in fact asking us to include our inputs, our arguments. However, if we have x cosine, and we don't typically write the multiplication, now Word isn't recognizing that most of that is actually just a single function. What I usually do is I just press space between each two factors. So x, press a space, cosine, and we're back in business. Now really watch out. Right now we're in the, right now we are in, it is probably not too visible unless I change it to light mode. There's like a dotted box. That means that Word is expecting that we give some kind of input. Do be careful. Let's say it's an equation. You don't want to type. What you don't want to type is this, where, see how it's shading it? I'm in the same input box. So what I need to do is, if I only want x squared, once I've typed it, once I've typed x squared, I need to, with my cursor, exit the input box and then continue typing. So is equal to, for example, square root, backslash square root. Go into the input box. Cube root is similar. It's a 4-letter command, CBRT. When you need higher powers, let's just enter, for example, x plus 1. So let's say I want the 5th root. The way I've always done it is I give a cube root regardless, and then you can actually edit that 3. So now I can edit the 3 and turn it into a 5th root. If I press fraction button, it really depends on the context. Let's see what happens over here. If I had to guess, it's going to place all of this right-hand side as a numerator. And in fact, that's what's happened over there. And now we can enter 45 minus tangent x. Okay, so these are the basics. Alt equals, that's how you start equation mode. Once you're in the equation editor, is how I'm going to refer to it. Most commands are pretty natural. So plus, minus, times, division, pretty easy. We don't have to enter any command, except for perhaps multiplication. Multiplication, it is cross. No, it's not cross, it's times. Times over there. Now let's say that you want to rewrite this equation and keep the equalities aligned. So first of all, you don't press enter. Enter completely exits what we're typing. Instead, place your cursor back into the equation editor, and I think it's shift enter. Shift enter, where they look like they are two different blocks of equations, but you can actually relate them to each other. So for instance, let's say we had to cross multiply So we have this 45. I'm going to very quickly show you how to align everything. Might be fast, just copy and paste like that, or drag and drop, keeping the control pressed so that it makes a copy. And you will align these equalities, provided that you used Shift Enter. This way, Word recognizes it as a single block in many ways. It is right click, and you see this align at this character. I usually just press G. You can see the G in align is underlined. That doesn't do anything, or it doesn't do anything yet. But when I do the same thing over here, now the equalities are under each other. So you can quickly see how this equation is being simplified, or how it's being rewritten. I would say these are the basics. Alt Enter is to create that equation editor. Watch out for what is in a box and what isn't in a box. So let's say I want to write that the integral /int between two limits, let's say, for example, between 0 and 1, so it's underscore and that arrow. Now I have a box. So what do you usually want in that box? You don't want dx, for example. You want dx out of the box. And then you'll enter whatever it is that you're integrating. And as an integrand, I'll try and take an easy one. And by that, I mean something that I don't have too many difficulties working with. So for example, this square brackets, x cubed over 3, again, underscore and arrow like this, and you're practically done. We can take the 1/3 out, and it is now x to the 1 minus 0 to the 1. I think I'm forgetting my calculus, aren't I? It's 1 cubed minus 0 cubed. And that's your final answer. You could place a full stop. How can you stagger these things? I could do Shift Enter over here, right click G, or else Shift 10 G, and Shift 10. Shift 10 is the same thing as when you right click Shift 10 G. And you get like this nice effect, like a staircase, where you're highlighting, this is what I've started with, there's nothing above or under it, and this is the last thing that I've typed. Again, nothing above it, nothing below it. It's quite easy to follow. It's not always possible to present this way. It really depends on the calculation. Right, now, what do we have in actuarial mathematics? What are the main things that we're working with? Let's start a new page. Well, matrices feature quite a bit. Now, how do I enter a matrix? Well, you need it in parentheses, typically. Parentheses are these. And then the shortcut is Alt. You're seeing Microsoft Word is telling you JE for equation. And that only comes up when you're working within an equation editor, meaning see, it's disappeared. So it disappears. So Alt JE. X for matrix, I'm looking at the rightmost segment of the menu bar, and you pick your matrix. And we'll pick a 3x3 matrix, for example. You need to see that I'm still in the brackets, still in the parentheses. There we go. And it might be a good idea actually to change the font color. This is usually what I use at work, because those boxes really aren't visible. So let me just do that right now. And we'll just take black. So Alt H FC, and we'll just take automatic. Hopefully the boxes are a bit more visible this way. Let's say you want to create, maybe you want to populate it with partial derivatives. similar to, for example, a Jacobian matrix, if you're familiar with the concept. So that's my fraction. I've just pressed slash and space. And then we need derivatives, but not exact derivatives, not your dy by dx, but partial derivatives. And I type backslash partial, can copy that, and say, for example, like this, and we'll do it with respect to, for example, x, after doing it with respect to y. So this is how, although usually the leading diagonal, you'd only have one variable. So your y variable and your z variable, it's a very natural way of writing these things. The idea is, I wouldn't necessarily recommend typing in Word the entire time of your studying, but if you're keeping the exams at the back of your mind, you will have to do them in Microsoft Word. So it's good to get maybe a couple of hours a week. Maybe if you're just creating slides or just revising, not necessarily when you're doing material for the first time, but to actually ask yourself, how would I type this equation in Word? Like I said, it really depends on 4 or 5 key ideas. Let's fill the rest in, just to get an idea of what this would look like. So we have this, but with respect to z, this, but y and x, this, but y and z. I'm just copying and pasting. It's very, very straight. It should be, I would imagine it's quite straightforward. This and this over here with y, actually with z and y. You don't need to, although I'm sure you will have quite a good idea of what this notation represents. Now let's give it a name. Call it J for Jacobi. Matrices are usually written non-italicized and in bold. So Control I removes the italicized font. Control B now places it in bold. So that's how you would enter a matrix. We can think of multiplying two matrices as well. We can take, for example, let's say Alt JE X, and we could take this, which would be 3 by 2, and we can multiply it by anything that is 2 by something. So for example, a 2 by 1. Again, Alt JE X, and 2 by 1 would be this one, I think, right? And what would that produce? So we have, how would you sort of signpost these things? You could do, I think I have it as a shortcut. So in my case, I press Alt 5. I think it's a really useful shortcut to have. We could discuss how to place such a shortcut in Microsoft Word. And this is where I keep the submenu of equation mode. It's labeled as the accents. If you want to place a dot above anything, think of differentiation in Newtonian notation, where instead of writing d by dy, you simply write a dot above the variable that you're differentiating. Think of 1/3 written as in its decimal expansion, where you have 3 is a recurring digit. So that's 2 ways where we use the dot accent, this sort of little arrow accent that's for angles. You have these arrows for all your vectors. You could place things in boxes, which is what certain authors use as, for example, to indicate that a specific value is maybe an answer to an earlier question. The one I find really useful, or the two I find really they do the same thing, are these two, where I can quickly write that this is a 3x2. If you disagree with that, do let me know. But I think it's a 3x2. Let's see if I can get it without my shortcut. So I typically press 5, just because in my Word workspace, I have accents as a sort of as a quick shortcut up there. But let's see if I type JE, so I'm in equation mode, and yeah, you have accents over there, A over here, A, and you get exactly the same menu that we accessed earlier. And you would pick this one, right? That this is a 2x1. And this should produce, this is a 3x1. Now there are actually two ways of creating a 3x1. I could either just pick it from the submenu over here. That's your 3x1. A much faster way is actually Shift Enter. Shift Enter, Shift Enter. The great thing is that you can have as many components as you like, well, theoretically at least, whereas the matrix menu only has these 8. Probably you could argue they are the 8 most commonly used matrices, although it's not necessarily the case that they get the job done for a specific question. How can I create matrices that have more than 3 rows and 3? That would appear to be. How am I not getting this right? Because I'm not in equation mode. So equation mode. Now I can do Alt JE X for matrices. How can I create matrices with, for instance, more than 3 rows or more than 3 columns? Well, 3x3 is a good place to start with, and we'll place this in parentheses. Doesn't need to be parentheses. You might be calculating the determinant of a matrix. So in that case, it's these 2 vertical lines. Place 3x3, and then you can actually do right-click or Shift F10. And it's asking, well, or you could specify insert a row before, a row above. So we can, why don't we insert a column after? And we'll do the same thing, but with a row underneath. And again, it's a lot easier to just press the underlined letters. So a much quicker way is Shift F10, I, and then N. And this is your 4x4 matrix. Pi is /pi. Euler's constant is just E. There is no shortcut. Greek letters, very natural way of doing them, just \, and then, well, we already did pi, in fact. So for example, alpha, it is case sensitive, just like in R. So if I want lowercase gamma, that's your gamma. If you want lowercase, how do you place it in a normal sentence? As soon as I exit the equation template, or whatever we've been calling it, and you really hit anything on your keyboard, could be a space, could be a symbol, could be a letter on your keyboard, then it's just going to go into normal sentence mode. So for example, how would I create a fully fledged sentence that mixes both equation mode and just your normal way of entering things? Just going to change the font. Big fan of Calibri Light. And why don't we it's been many, many years since I last thought of the precise definition of continuity or limit. But I could just as a bit of fun. So definition, and it's the epsilon delta. So for example, I really don't like those brackets. So I think the brackets would be normal brackets. Then you go into equation mode. Epsilon. Then I exit, do a dash, and then I do delta. Epsilon delta. Let's say epsilon delta formulation, and let's put that in bold, and we'll type. I could do it in two ways. I could speak of continuity, or else I could speak of limit. Let me speak of continuity. So continuity is a characteristic that a function may or may not have. Now, to even speak of continuity, you need this concept of a topology. Topology is a generalization of distances. So go back to your Pythagoras' theorem at secondary school, where you can quite easily calculate the distance between two fixed points in a coordinate system by using their coordinates. It could be one-dimensional, in a one-dimensional setting, in a two-dimensional plane, in three-dimensional space. And I'm going to write, I'll take a special case. So a function f, and then I do a space, colon, from the real line to the real line. So it's a real valued function on a subset of the real line, perhaps. Maybe I'll take this as A, where A is just a collection of real numbers. For example, all the positives, or all the evens, or all the numbers greater than 5 but less than 7. A function f from, where A is a subset of the real line. So A contains exclusively real numbers, pi, -1,000,000, etc., is said to be continuous at, and let's just take some input, x0 in A, if, just zoom out a little bit. And again, the idea is, I'm having a bit of fun with this definition. It's something that I haven't thought of in a rigorous way many years. The point of this session is not to understand, although it's not too difficult to get at least an intuitive idea of what I'm saying over here. The idea is just to see how we're kind of, this is like a hybrid model where we have equation editor together with normal text is said to be continuous at x0 is an element of A if for every delta, for every epsilon greater than 0, if you want greater than or equal to 0, you just type greater than, then you just type equals, and it does it automatically. There is also, you could do greater or equal, GEQ. That's probably a long way. If you just do greater than, and then you just press the equals button, you have greater than or equal to. But in the definition, it's greater than 0 if for every epsilon greater than 0, there is a delta also greater than 0, such that for every, now this is for every x in the neighborhood of x naught. What do we mean by the neighborhood? So you have x naught, and we're going to say all those x's close to x naught. How close? Well, their distance isn't more than delta from x naught. And how do you quantify distance in mathematics? There's this absolute value, at least distances in the real line, such that for every x minus x naught, and that's underscore x naught, less than 0, excuse me, less than delta. So for all these x's in the real line, so for every, such that for every x in, I guess, A, satisfying this, then the output of that x is close to the output of x naught. Again, the idea is just to see how you write all this, including elements which rely on this equation mode function. So definition, epsilon delta formulation, a function, f mapping every element in the set A to the real line, where A is also a set of real numbers, is said to be continuous, and you might want to emphasize that. Continuous at x naught is an element of A if for every epsilon greater than 0, there is a delta greater than 0, such that for every x in A satisfying that inequality, then f of x satisfies this inequality. At some point, I'd really like to do a session on these epsilon delta formulations. You use them to define continuity. I thought this was in bold. Also the limit of a function. I'll do one last thing, which is quite important to most mathematics, financial mathematics and actuarial science are no exception. How to define, how to type out a series. So equation mode, you don't type sigma. Instead, you type sum. Because if you type sum, when you underscore and do that little arrow, Word is going to place them below and above the sigma notation. So I'll just write 1 and 1, but I'll edit them. I'll say from r equals 1 to r equals 100. We don't normally write r equals 100. We normally just write 100. And for example, we could take a harmonic series, which is 1 over r. Oh, maybe you want to take something else. But what this would mean that it is equal to, not identical to, right? It is equal to 1 plus 1/2 plus 1/3 plus ... and it renders them automatically. So I'll just do it again, ... and then you can write your final 2 values, for instance, your final 2 terms. 1 all over 100. Do you have any requests? Is there something specific that you'd like me to type out? Maybe something you've been working on recently? All right then. So we're going to stop over here.